Okay, so remember that yesterday we looked at increasing and decreasing functions. Now, I'm just going to go over this briefly, and if you're watching the video, then you may want to pause this to write all this down. But we kind of looked at, given a graph, could we find the relative maxes and mins? Could we figure out where that graph is increasing and decreasing? All right? And then we looked at some rules. The derivative of a function that is always increasing, or that is increasing, will always be positive. We got a decreasing function being negative, a constant function, the derivative is 0, and then where the change happens is your relative extrema. So what we're going to do today is actually work with some equations and figure out where those equations or where those functions are increasing, decreasing, and the relative extrema. So we have this theorem. It doesn't have any special name. It's just theorem 3.5. We're not going to do a theorem write-up over it. So it really is just a test for increasing and decreasing. So we have f. We have a function that's continuous on the closed interval. Sound familiar? Same stuff as before and differentiable. Okay? If f prime is greater than 0, in other words, f prime is positive, then f is increasing. This is what we just said yesterday on the previous page, just in reverse order. If f prime is negative, then f is decreasing. And if f prime is equal to 0, then f is constant. So when presented with a problem like a function and say find the intervals where f is increasing or decreasing, we need to find the derivative. I hope that's kind of on your mind. First, you have to find f prime of x. Now, we just had a whole chapter over this, so you should be experts at this by now. All right? Especially on a polynomial like this. So 3x squared minus 3x. All right, now we need to find the critical numbers. How do you do that? Set the derivative equal to 0. What else do you need to consider? Where the derivative is, there's a second scenario, where the derivative is 0 and where the derivative is undefined. That's not an issue in this problem because a parabola, x squared, is never undefined. We'll see that, though, on another example before today ends. Equals 0. So how do I solve this? Factor. Factor out a 3x. You're left with x minus 1. Then you set each factor equal to 0. Now, I do want to address something really quick. If you factor out a 3x, you can divide both sides by 3 and say that x equals 0. However, if you only factor out a 3 without the x, does 3 equal 0? No. So some people messed up a little bit on the quiz yesterday. Okay? Because on the quiz, you could only factor out, I think it was a 2. That doesn't even give you a critical number. Okay? So what is the other critical number in this problem? X equals 1. I know a lot of the examples we do have 2 critical numbers, but there really could be 5, there could be 1, you know, there could be none. That's possible. It's kind of be a boring problem, but all right, so those are our critical numbers. So this is what we're going to do next, and this part is new. We are going to draw what looks kind of like a number line, all right? And it's going to go from negative infinity to infinity, and you're going to put your critical numbers in order. The in order part is really important. If they're not in order, it kind of screws up the whole problem. Okay. Next thing, you're going to put f prime down here and f up there. In other words, what we're making is called a sign chart. Sign, not like sine, cosine, sign like plus, minus. So this is not a graph. It's just a chart for me to organize my information. So I am going to take a number between negative infinity and 0, and I am going to plug it in to the derivative, either the derivative that we got at the beginning, or I could use the factored derivative. And I'm going to decide if the numbers over here give me a positive or negative derivative, and then that's going to tell me if that part of the graph is increasing or decreasing. So what number do you think would be easy to plug in over here? -1? You could really pick any number you wanted, but I agree, -1 is pretty easy to plug in. When you plug in a -1, I'm going to draw a little arrow, because I want y'all to know you're plugging it into the derivative. We're not finding y values. We're finding out if f prime is positive or negative. So if you plug in a -1, do you get a negative or positive result? Positive? Does everybody agree? If you plug in -1, 3 times -1 squared minus 3 times -1, you get positive. And that would be true for any number on the interval. Any number, -2, -10 billion, any of these numbers, you plug into the derivative is positive, that tells us that this interval, f is increasing. And we're going to draw a picture. You could write the word increasing or INC, that would be fine. I'm going to draw the picture. All right, now we got a test between 0 and 1. All right, so what number do you think? 1/2? We got to pick a fraction. We can't get out of that one. So if you plug in 1/2, don't think you got to crunch the numbers all the way. You just have to decide if the result is positive or negative. So 3 times 1/2 times 1/2 minus 1. Is that going to end up being positive or negative?
Negative.
It's going to be, which one? I mean, it is positive or negative, but which one?
Negative.
It has to be negative. So 1/2 minus 1 is a negative number, and a negative times a positive. And you know what? If you need to go through and actually find the number, you can. You don't have to like think of this in theory, but you don't have to write down negative what. You just have to know that it's negative. The derivative is negative. All right. What is a number greater than 1 that we could pick? 2. I like the enthusiasm. So when you plug in 2 into the derivative, again, you can plug it into this 3x squared minus 3x or the factor form. It doesn't matter. One might be a little easier than the other, but they'll both give you the same result. You get positive. Therefore, the function is increasing. Now, before we actually write out our answer, are there any questions on how I came up with positives and negatives and anything like that? Okay, so all the information I need is right here. I got to write it out though. So this is how we're going to do this. We're going to say f is increasing on, and then you're going to write the interval for which f is increasing. So I see an increasing arrow right here, so I'm going to say -∞ to 0. And then increasing again from 1 to infinity. So these are all the x values for which our function is increasing. Then you have to write a because statement. Feel free to write B/C for because. You can abbreviate all you want here. That's totally fine. But we have to write a reason. Okay? So how did I know? I mean, if you're thinking, well, what am I supposed to write? Because why? Well, how did you know that f is increasing?
It's a positive slope.
Because f prime is positive. And I like that you use the word slope, but I'm not going to use it in my answer, only because I have to refer to the derivative. So I'm going to say because f prime is greater than 0. You definitely could have said instead, because f prime is positive. Those two statements mean the same thing. F prime greater than 0, f prime positive, same thing. Yes?
So you put the 0 and the 1 and give us the critical numbers?
Yes, because what's the derivative at those two numbers?
0.
0. So around them is where we're getting change from positive to negative. All right, so now we got to write the other statement. F is decreasing on, so what would be the interval for this one? 0 to 1. And again, we have to say because f prime is what? We could say is less than 0, or we could definitely say because f prime is negative. It doesn't matter which one you use. If you get your less thans and excuse me, less thans and greater thans mixed up, you need to go to plus minus. All right, it doesn't matter. They're both acceptable and they mean the same thing. So this right here is your answer. Anytime you're doing increasing and decreasing, you always want to write y. That's implied that you have to write that in this class. All right, now, once you've identified these intervals, you can actually figure out your relative max and min. Do you see it? I mean, look at this. This isn't really a graph, but if I kind of follow it, yeah, so which one is 0? The relative min or max? It's the relative max, and this one is the relative min, which brings us to the next theorem.
But if you have multiple, then you can't.
You could, well that's...
You can tell they're relative, but not absolute.
You're right. This doesn't really tell us about absolute. To do absolute, I would have to plug these back into the original, and I would also have to have endpoints to plug back into the original. So first derivative test. Okay, again, theorem 3.6, we're not going to do a theorem write-up over. All right, but if you're going to do the same thing. So if my directions were not to find intervals for increasing, decreasing, but for relative max and min, you're still going to find the derivative, find the critical numbers, do the sign chart. You're just going to analyze it a little bit differently. So this is how we would write our answer for 4. Okay, we would say f has a relative, it doesn't matter which one we'll start, we'll just do the max because that's the first one. F has a relative max. And then you'd say at, it's not an interval, max is happening at one point. So you'd say at x equals 0. It's not that 0 is the max. 0 is the location, it's the x value of the max. And then I have to write a because statement. Now this because is a little bit different. All right, you got to say because f prime changes from, and then just look at your sign chart, because it's going to be really easy to get this mixed up. Changes plus to minus. Changes positive to negative. And you can abbreviate. You don't have to actually write out positive and negative. You can write plus and minus. And I can see right here the maximum is positive to negative. This is really easy to get mixed up. I wouldn't memorize it. I would just go based off of the sign chart. So then my next statement would be f has a relative min at x equals 1. And again, you have to write because f prime changes from, look at your sign chart, at x equals 1, f prime is changing from negative to positive. You can't just say changing signs. You have to actually say it's changing from this to this. Okay? So not too bad. Not totally different than what we've been doing. The sign chart thing is maybe new. Maybe you saw this in pre-cal. If you were in pre-AP, you might have seen this in another context. All right, let's look at number 5. We got a trig problem. Control your enthusiasm. I know how much you guys love trig. So notice the directions here are just to find the relative extrema. So we don't have to do increasing and decreasing, but we're still going to do the sign chart, so it's pretty much going to be approached the same way. So what's the first thing we need to do? Derivative. So go ahead and do that. Find the derivative. F prime of x equals 1/2 minus cosine x. And we need to check for 2 things on the derivative, where the derivative is 0 and where the derivative is undefined. Is cosine x, or 1/2 minus cosine x, is that ever undefined? I mean, think about the cosine curve. This is just like shifted up and flipped over. Are there any holes or vertical asymptotes or anything like that in a cosine curve? No. Is there any chance I'm going to divide by 0? No. So you don't have to worry about the undefined. The next one we do, the undefined thing will be a little bit more obvious. So all we have to do here is set this equal to 0 and solve for x. Now when you're doing trig, you can't just get x by itself in one term. You have to first get cosine x by itself. And so that would be equals 1/2. All right, this is where everybody today was like, I hate trig. I want to be done with trig. We're never going to be done with trig though. Okay, cosine of what equals 1/2? Now, keep in mind, we're in the first revolution. So watch this. I'm going to remind you guys, all students take calculus, right? So pi over 3, how'd you get that?
Because triangles.
Yeah, because of the 30, 60, 90 triangle at SOHCAHTOA, and maybe you've done this enough times where it's kind of like in your brain somewhere. But yeah, cosine of 60 degrees, some of you may have been thinking 60 degrees, we're going to use radians in here, pi over 3. But there's actually another one. So what you did is you picked the one in the first quadrant. Where else is cosine positive 1/2? Yeah, the fourth quadrant, so I'm going to cross those out. That's where cosine's negative. So the other one is 5 pi over 3. So how did you girls figure that out so fast? Do you just remember it?
Because it's still positive. If it has a positive x value, then your hypotenuse is always positive. So
right.
It doesn't matter if the sign is negative.
So to find a pi over 3 in the fourth quadrant, basically you're just subtracting pi over 3 from 2 pi. That's how you did this originally in trig. All right, so now that we got past that, those are our two critical numbers. We needed to put these on a sign chart. Now, because sine and cosine go on forever and ever, they typically give you a little interval to stick with, okay? Because really there are infinitely many answers to this, but only 2 in the first revolution. So see how it says start at 0? I'm going to put 0 on here, and I'm going to scratch out everything to the left of 0. I don't care about those numbers. And I'm going to do the same thing over here. So we're not going negative infinity to infinity. We're starting and stopping at 0 and 2 pi. I'm still going to put the derivative down here and just plain f up there. And I'm still going to test. So what would be something good to test between 0 and pi over 3? So pi over 3 is 60 degrees. So give me maybe degrees. That's less. Pi over 4 or pi over 6 either. Okay? So you could do it either way. Now I'm going to go ahead and go off to the side here. I'm going to do pi over 6. What is cosine of pi over 6? You just got to practice it. The more you practice the stuff, the easier it'll be. It's radical 3 over 2. Now, I don't really care what this equals. I just want to know, is it positive or negative? When you subtract 1 minus root 3, is that going to be a positive or negative number? It's going to be a negative number. Do you know what root 3 is about? It's about 1.7. Okay? What's the date for St. Patrick's Day? March 17th. 317. Square root of 3 is about 1.7. Have you ever heard that before? You don't really have much need for it, but it was kind of useful right here. Okay, Valentine's Day? What is that? 214, right? Square root of 2 is about 1.4. Now, this there's some leniency there with the whole abouts, but that will help you in problems like this. If you're ever doing this without a calculator. If that's all you learned today, no, I'm just hopefully you learn more than that. All right, so we have a negative, right? And so that means that my function is decreasing between 0 and pi over 3. All right, what can I pick that's between pi over 3 and 5 pi over 3? Would be easy.
2 pi over 3.
Okay, 2 pi over 3 is not what I would say is easy.
3 pi over 3. Pi.
I would pick pi. But honestly, it doesn't matter what you pick. You should all get the same answer. What is cosine of pi?
1. -1.
So 1/2 minus -1. We don't have to evaluate it. We just have to know positive, negative. And some of you are like, I can't do that fast. That's okay. Okay, just go off to the side, crunch the numbers. You are all smart enough to do that. You may need a little bit more time than what I'm doing right now. Now, if you had a guess for the third one, what would you think it is?
Negative.
Have you noticed how we've kind of been flipping back and forth? It won't always happen that way, but it does a lot of the time. All right? So here, you might want to pick something like, you're going to have kind of can't pick a whole lot of stuff. I don't know why I put row 5. I'm going to pick something like 11 pi over 6. And that becomes 1/2, and again, minus root 3 over 2. That's negative. So like that. So now I need to write my answer. Okay, we don't have to write down the increasing, decreasing. You've got to write down the relative extrema. So I'm going to say F has a relative, it doesn't matter where you start, I'll start with min, at what? Which one is the min? And connect it if you need to. Do like that if you need to. Pi over 3. Because F prime changes from, if you don't have it memorized, that's okay, just look right here. Negative to positive. The sign chart will tell you. And then we go, F has a relative max. At. Well, that's a max right there. So X equals 5 pi over 3 because F prime changes. And again, if you don't know, just look right here, positive to negative. Okay? It's totally cool if you abbreviate, but you gotta have all those pieces in your answer. Alright, so we're done with the trig one. Now let's work one with a little bit more algebra. Okay, what's the first thing we gotta do, guys? Everybody. Derive it. So f prime of x equals, what's gonna be the derivative? So 2/3 x squared minus 4 to the negative 1/3 times 2x. I hate to say this, but if you mess up here, it kind of messes up the whole rest of the problem. So you want to be really good at derivatives. If you're still struggling with this, you need to come to tutoring. You need to get with me, someone else maybe that's really good at deriving. I can help you with this. Now, this is a very messy derivative. It would be better for me and for you if you can rewrite it so that it makes more sense. So this is what I mean by that. Okay, see how we have a negative exponent? That means you're going to have a fraction. So out of all of this, which pieces are actually belong in the numerator? 2 and 2x. See this 2 right there? That's a numerator. This 2x, that's a numerator. So what goes in the numerator? 4x. We'll get to that. So the 3 we know is in the denominator. See how this is to the negative power? Where does negative power stuff go? To the denominator. And the 1/3, what does that mean? Cube root. So I'm going to write the cube root in the denominator. The negative is the denominator, the cubed root is the 1/3. And then I'm going to go x squared minus 4. Okay, this is going to be a lot easier to work with because what I have to do now is figure out where is this derivative undefined and where is it 0. I'm going to explain this, but in the end, it's actually really easy what we have to do, okay? if you want to know when a fraction is 0, which piece of the fraction are you really looking at? If the whole thing is 0, what really only needs to be 0? The top, the numerator. Yeah, you're right. Because if 4x is 0, what's 0 divided by some random number? 0. So then x equals 0 is our critical number. That's one of them. So here's the other side. When is something a fraction, specifically undefined? When the denominator is 0. So this is then we're going to go 3 times the cubed root of x squared minus 4 equals 0. Now, if you're like, that is a lot to remember. This is what you need to remember. Set the top equal to 0, set the bottom equal to 0. Set both things equal to 0. You're good to go. Okay?
Oh, it's so easy.
All right. So it's easy when you know it, right? Everything's easy when you know it.
It's so easy when you.
So what would you do next?
Divide by 3.
Divide by 3. Are y'all okay if I just scratch it out? Because 0 divided by 3 is still just 0. All right. What are we going to do next?
Cube it.
Cube it. So then you got x squared minus 4 equals 0. What are we going to do now? Add 4. We could factor actually right now. Let's go with add 4 though. And then so what is just x? Plus or minus 2. If you had factored, you still would have gotten plus or minus 2. So we have 3 critical numbers.
Oh my god.
We haven't seen this yet. All right. Here's the kicker. You can't write 0. Watch, don't write this. This is what I see sometimes. What's wrong with that?
It's out of order.
It is out of order. And remember, that's something you did a long time ago. Is your teacher had you write numbers in order. And the whole reason is to do this lesson. I'm just kidding. It's for a lot of reasons. But and I'm going to go ahead and put my little infinities at the end. All right. Because it's the end of the day, let's split this up. Okay? You three, you guys are going to test a number between negative infinity and negative 2. You guys, these three are going to test between negative 2 and 0. You three are going to test between 0 and 2. Last row, you got a number greater than 2. So remember, you're plugging in a number into the derivative. We're plugging it into the derivative because I want to know, is the derivative plus minus? Okay? So go ahead and do it, and then compare your either whether it's plus or minus with your front and back neighbors, your row. See if you got the same thing. You don't have to pick the same number as your row or your column. You should have the same result, though. Okay, first group. Did you guys get yours? What'd you get? You got a 50-50 chance, even if you're not sure. If you plug in a number that's less than negative 2, you get a negative on top, and that's going to create a positive on the bottom, so the result should be negative. Okay, next group. What'd you guys get?
Positive.
Positive. Okay, next group. Negative. Last group.
Positive.
All right, now, you're kind of starting to think, Miss Brooks, we don't need to do this work. It's always just going to flip-flop, positive, negative, positive, negative. And I'm going to tell you, there actually is an exception to this rule, and you'll see one on your review sheet like that, okay? And And that means there definitely could be one on the test like that. You need to test every single section. All right? Let me finish writing this down and I'm going to address your question. Okay? So we need to go ahead and finish writing our answer. So we're going to say F has a relative min. It doesn't matter which one you start with. We'll just start with min. And look, we have two mins. See this? We have two mins. So we have to say at x equals -2 and at x equals 2. Then we got to write our statement because f prime changes from, if you don't remember, just look up here, negative to positive. The next one, f has a relative max at x equals 0 because f prime changes positive to negative. So let me just address the question of, and we're not going to do C, by the way, but let me address the question of why it doesn't always flip. Okay? It could be, I don't know why I did that. It could be that you have, say, 1 and 5, and it goes like this, plus, plus, minus. And it looks like this. What this graph would look like is a graph that goes up, levels off, goes up again, and then comes down. This is still a critical point because what's the derivative right there? Still 0. So just because a graph levels off doesn't mean it has to come back down. It could level off and go back up. I was going to talk about this tomorrow, but go ahead, why not? That thing right there is called a saddle point. You do not have to know that phrase, but I think it's kind of interesting. It's called a saddle point. A saddle point is just one of those places where the graph levels off, but it doesn't end up being relative extrema. Okay? There will be one like this on your review. It's not any different, though. You need to know just to test every interval. What would be another reason why you want to test every interval instead of just saying, the first one's this, so let me just finish the rest of it? You could be wrong for one. You could have messed up on the first one. So it's a really good way for you to check your work at the same time. Just make sure you do each one. Most of the time, it is going to flip-flop, but not every time.
For the example you did, does it have some relative minimum?
So for the last example that I did, this in blue right here, so there is no relative min on this last one that I did. Did y'all hear Gabby's question? There is no relative min on the last problem that I did. There's one relative max, but there's no relative min. Because thinking of this definition, the derivative never changes negative to positive. Okay.